G'day guys, thanks for tuning in. Today we're going to go through the configuration of a Naze32 board. It's derived from a video that I'd previously completed, scratch building the Squirrel 360, and within that process of building the quad, I went through configuring the Naze32 board with Baseflight. The video quality wasn't really good, so I thought it best to redo it so that we had a better video quality, and secondly I wanted it as a standalone configuration guide that people could just select from my website or from YouTube to work out how to just do the base configuration for Naze32. So I really hope you find this useful, and any feedback is always appreciated, so please post your comments on what you find good about it and what you don't find good about it. So let's get cracking. Baseflight is an add-on onto Google's Chrome, so we'll just start Google Chrome, and the way to find it is you just write in Baseflight configurator, and there we go, it's in the Chrome Web Store. I've already downloaded it to my Mac, and of course there is a Windows version available, but it brings you to the web store, and there we have the configurator. It's a matter of, in this case, instead of launching the app, we would select download it, and then it'll create a little icon that you can quickly launch your apps from. So there's the Chrome app launcher. So this is how I typically would launch it. Click on it, and there's my Baseflight configurator. So we'll kick that off, and we hit the landing page. I've got a Naze32 board sitting in front of me, so what I'll do is I'll plug that in, and I'll show you how you go about getting connection. So it's a USB connection, and it's already given us a little bit of an issue. We saw here that it opened the port, but then it closed it immediately. Look, there's our issue, and I knew I would have to do this. This is a brand new board, and Baseflight has just updated itself. What it's asking me to do is actually update the firmware. So that's fine, because that was going to be the first point of call of what I was going to do. If we look down here to the right hand side, we see that there's a firmware flasher. We'll select that, and what I like to do is use the repository that's online. So there's a couple options here. We can load firmware from a local resource or a firmware from an online resource. So what I'll do is I'll select the load firmware from online, and we'll flash the firmware. So up here we'll see that it's erasing and flashing, and then it will go on to a verifying. There we go. And done. So just for your knowledge, the Naze board flashed, I don't know, maybe 4 or 5 times red, and then it flashed green a little bit, and now I've only got the blue light on. I suspect if we just hit connect, it'll work. Fantastic, there we go. So now we're presented with the landing page, which is the setup. There are a number of pages that we'll look at visiting. However, for the purpose of this, we'll do one at a time, and I'll try to explain each component of it as we go through. The landing page really shows you a little bit about the board, so I'm just picking the board up and moving it, and we can see that we get a orientation of the board, or in this case when it's mounted into a quad, the quad itself. What you need to do for the initial portion of setting up the board is ensure that the quad is on a level surface, and then we need to go through and calibrate the accelerometer. So it's a matter of selecting calibrate accelerometer. It goes off here, that starts it, and it's finished it. If we reset the Z-axis, what we'll actually get is the arrow pointing in this direction relative to us. And so we can see that if I pitch it forward and backwards, or left and right, it actually does what it's supposed to. And there's a yaw as well. I'll just reset that, and there we go. So it's a level quad again. That's probably all I really use from a setup perspective on the setup page. The next page that's interesting is the CLI. We should do a number of CLI inputs to set the minimum configuration to the board, and what I do is refer to my cheat sheet, which is set on my Google site under CFury-Mike. So a quick search gets me to my site, and what we'll see here is that down the left hand side I've got a number of configurations and I suppose information that I've accumulated over time and placed them there for reference. So we'll select the Naze32 and we see just some of the configuration parameters and the board diagram itself. So from a Naze perspective, that's the typical revision 5 of the board. And just for your reference, if you go to AbuseMark, and I'll just do a search on Rev3 manual, which is the latest one at this point in time, you'll see that you can get the revision 3 manual. I recommend downloading this as well. So there's abusemark.com, downloads Naze32 Rev3 PDF, and it's got a lot of good information. And when it finally downloads off my really slow internet connection, you'll see that I've actually extracted that picture from the manual. And the manual, of course, gives you all of the configuration for the hardware itself. So these are the outputs for telemetry, buzzer and battery connections. Just off to the left here there's a number of pads which you normally solder on some header pins, and they're your inputs from your receiver, and these are the outputs for the motor. So there's 6 outputs with the signal wire actually being towards the center of the board, and the numbering of the motors goes 1, 2, 3, 4, 5 and 6. So that's probably the most important aspect of this board. We'll head back to my site, and I've got a heading here which says minimum configuration. In short, these are the features and settings that I use as a minimum to get my board going. So the first one is feature PPM. So in other words, what we'll be doing is taking the interface of the board from the receiver from an 8 discrete channels and multiplexing them all onto a single channel. So all 8 are available on one single wire. And what that basically means, if we just go back to the board, is that from memory that's the negative pin, that's the positive pin, and that's the first signal wire. So all of those 8 channels are now multiplexed onto this one single wire. So you only need to configure 3 wires from your receiver. And of course your receiver must be capable of doing PPM output, and you need to set that mode as well. So what I'll do is I'll grab that and I'll copy it, and we'll go back to the baseflight configurator and we'll enter that command. I just want to enter one command before I start, which is feature. So if we enter feature, it gives you an output of what's currently enabled. So we see here that V battery, which is basically the ability of the board to output or receive the battery voltage from an external source, is enabled. In this case, we want to turn on a second feature, which is PPM. So I'll enable that by just entering feature PPM, and it comes back with enabled PPM. So if we do feature again as a command, you'll see that we have PPM and VBAT now enabled. In case you want to actually turn off a feature, In other words, you actually want to disable it. It's as simple as negating the command with a minus sign. So you just put a negative in front, and let's try VBAT. So we now see that VBAT is disabled. And if we do feature, again as an output, we only see ppm. We'll just re-enable VBAT, and I'll just get rid of the negative and enter it. Excellent. The next configuration that we want to see, of course it's been a little bit painful because it won't tab to it, is motor stop. Copy that. So feature motor stop is useful, for me at least, when I configure the quad in its initial settings. So there'll be a lot of configuration of the quad where the motors might spin because you've enabled the motor itself. So you want to check motor outputs and so forth like that. What we do is normally disable that ability. So I always recommend, of course, not to do any of this configuration with the propellers on, but you know, even not to scare yourself, it's a good idea to enable motor stop. However, when I do use this quad to go flying, I actually like to have the motors turn on. So in other words, when I arm the board, I will hear and see, if I'm not already under my goggles, the motors spin. It also gives a visual warning to other people, the fact that the motor is actually alive and that the board's alive. And I think that that's a nice safety feature. A lot of people just don't like it and they have it disabled all the time. So I've just entered that command and motor stop is enabled, as we can see here. The next command that I will need is VBAT. Well, that's already done by default. Set alignment board yaw equal to 90. Well, that one there is a important command for people that change the orientation of their board. On the board itself, so if we look at the manual, you'll see that there's an arrow. That arrow indicates the direction of flight. Now, if we were to move the board around 90 degrees and have it facing east, the arrow will point in this direction. For this to work correctly and for the mass within the board to work, we actually need to put an offset, and the offset is a yaw offset, and it's basically the coordinates of 90 or 0, 90, 180, 270. So if the board was to be orientated to the right, you would put an offset of 90 degrees. If the arrow was to point backwards, you put an offset of 180 degrees, and if you wanted the board to orientate to the left, you would put an offset of 270 degrees. Now the question is, why would you probably change the orientation of the board? And simply it is that in the back here, as you can see, there is a micro USB port, and that's the port that we use to do the configuration. It's the port that you would have plugged the board into to get connectivity to the base flight configurator. Generally behind here is where you put your battery. So I typically have my board orientated with the arrow pointing east, so that the mini USB port is on the left hand side here, and it just makes it easier for me to connect in case I've got batteries positioned in the back here. So that's what this board alignment yaw is for. So in this case it's at 90 degrees. So we'll go to the configurator and we'll set the 90 degrees and it's taken. So board alignment's now at 90. The next important command to add is mid-RC. A lot of these commands are probably defaulted to these values. However, I do like to add them in just to make sure that they're actually set. And I know that from a minimum configuration, everything's set correctly. So we set the mid-RC to 1500. So that's basically all the channels will have 1500 as their midpoint. And that typically aligns with all of the transmitter mappings as well. Next is map AETR1234. You go, oh, what the hell does that mean? Well, simply put, it really is the channel output. So as I said before, we've got 8 channels. Channel 1, 2, 3, 4, 5, 6, 7, 8. In this case, it really means aileron, elevator, throttle, and rudder. It's telling which channel does what. And these are your auxiliary ports, auxiliary 1, 2, 3, and 4. So that's all we're really setting. There is the capability of changing that around, but I stay to the default AETR1234. Next on there is minimum throttle and maximum throttle. So we want to set these two. Well, I set it to 1068 for a minimum throttle, and I set 2000 for the maximum throttle. Now, from reading some of the forums, there seems to be an 800 hertz resolution within the Naze boards themselves. So typically what that really means is that from 1068 up to 1868 will be the resolution that we can see within the board. So 2000 is well above it. But what I'm finding is that by setting these values, that the board works correctly, and I don't have any issues with the throttle maxing out and the quad not disarming properly, because my throttle values are say above or be not above enough or not below enough these minimum settings. So that's why I typically set those figures as I've got within this configurator. So there's set max throttle, and I'll just add that in. And next we'll set loop time. Now loop time is a very important command to make sure you've got right, and it's going to vary according to the type of ESCs that you use. So in my case, my ESCs are Simon K flashed ESCs, and they're 400 hertz. So a loop time of 2500 equates to 400 hertz. So if we actually scroll down to the bottom of my web page here, we see that I've actually put out the different values for the different frequencies. So for 400 hertz ESCs, we need a loop time of 2500. Next, we're nearly there, is to set the ACC low pass filter, and I'll add that in. And lastly is the EMF avoidance of 1. Whoops. So if we go back to my web page, I've got an explanation of the low pass filter, and basically it's just a filter to reduce some of the noise that might be seen by the board. In other words, it'll give us a little bit better control, and it won't read as much of the noise that's induced by the vibrations from say the motors and so forth. But of course it's always best to minimize any vibrations where possible. Now lastly but least, what we need to do is save this. So we enter the command save, and the board goes off and it reboots. So if we head back to the configuration tab, we get quite a lot of information in this new version consolidated. In other words, you'll notice here on the right hand side under the features that the PPM and the battery voltage monitoring and not to spin the motors is highlighted. There's a number of other aspects that we can enable and disable now through here. It's also good in that it tells us the quad type, so there's a number of options that are supported all the way through to custom, which I don't know how that would go, but and it also gives you good information around the position of the motors and the direction that each motor spins at. So strangely enough, contrary to OpenPilot where the motors are 1, 2, 3 and 4, here it's 1, 2, 3 and 4. However, the motor spin direction is constant with 1 and 4 being in the same direction and 2 and 3 being in the same direction. So when you place your props onto your motors, make sure that the motors spin in the right direction and that you've got the right props for that direction of spin. From memory, these are the right hand props and these are the normal props. So you'll have right hand here, normal here, right hand here, and normal here. Some of the other settings that we put in are also now shown on this page. 1068 for the minimum throttle, mid-range 1500 and 2000 for the maximum throttle. We'll use this min command later on to do ESC calibration, and there's a failsafe throttle here which you can set at whatever value you feel is appropriate for your type of aircraft. I would probably recommend that you would set this very low in the case of a receiver failure so that it just drops out of the sky instead of setting it up around 2000, which is full throttle, which under certain circumstances would either cause a runaway quad, or even at 1500, thinking that it might slowly bring the quad down. Hopefully if it stays vertical, I would suggest that even that is probably not a viable option, that you're better off just setting minimum throttle so that it just falls out of the sky, and you can just deal with the consequences of it basically through crashing and so forth like that. There's some other bits and pieces, so there's accelerometer and magnetometer outputs and some battery voltage, board alignment, so now it's already placed as an option down here. There's the setting of 90-degree offset that we put in, and there's other inputs for current sensors and so forth. I think it's prudent at this stage that I just go through some of the values up the top here. The board that I've got here is one of the full versions of the board, so it's got a gyro and accelerometer in addition to the magnetometer and barometer, which are basically options for heading hold and for altitude hold. And these are selectable within the configuration of this configuration tool because they're highlighted green. And you'll see here that GPS and sonar are red, indicating that these options are not available on this board. So on the Naze32 Acro, you'll find that you'll have gyro accelerometer, but you won't have a magnetometer or barometer, and they'll be red. So you only have the gyro and XL is a green option. That's probably all we need to discuss on this page. PID tuning. This is a important page. It's the proportional, integral and derivative setting for the quad. A lot of people typically will start with the quad and these settings, and then it's a matter of adjusting up or down the behavior or the values so that you can change the behavior of the quad. PID tuning, there's a fair bit to it, but in essence, if your quad is oscillating reasonably fast, what you're probably best to do is reduce your proportional value, and a good guide would be to reduce it in values of maybe 0.3 at a time and fly it again. And the integral value is typically adjusted in rate mode so that when you set an angle of attack for the quad, it should maintain that angle of attack. If it tends to drop in or out of that angle, so in other words it drops forward or it comes back and starts to self-level out, you'll typically need to increase the integral value around that so that it holds that angle better. And the derivative. So the derivative is kind of like a debounce. Think of it as if you've banked the quad and leveled it, what it'll tend to do is if it levels and stays put, that's great. That's what you want. But if it levels itself and oscillates just a little bit, well, you can get rid of that oscillation by adding derivative. And it's just a matter of increasing the derivative until you can get rid of that little after effect of bouncing. And it's very noticeable in the FPV goggle setup, not so much within line of sight. It's quite difficult to sort of see. The other thing that is useful on this page is roll and pitch rate. So I typically set roll and pitch rate to 0.5 as my starting point, and I really haven't changed that. And that's its sensitivity for rolling and pitching. The other one that I do is yaw rate, and I like mine quite sensitive in the yaw. So the higher that you get to 1, the more sensitive will be within that axis. So 0.8 is quite sensitive. For initial setup for people just starting to use a board, I would recommend a yaw rate maybe of 0.5. And if you find it a bit sluggish, start increasing it, safely knowing that you can get to 0.8 without it going stupid. You might want to set 0.5, especially for tricopters, because they're a lot more sensitive in the yaw. And lastly, on this column is TPA, which is throttle pit attenuation. My initial settings with TPA are 0.3. And what it specifically does is reduce the p-value when the throttle is increased. So as the throttle increases, the sensitivity of the proportional value for roll, pitch and yaw goes down automatically. So it's a software defined change, and what it will do is as you start increasing above 30% throttle, these proportional values will start to decrease, and I'm not sure if it's linearly, but I suspect it would be. I haven't read the source code around that, but these will start to become less sensitive, because when you fly quad, you'll find that the flight characteristics between hover and slow flight and high-speed flight are very different, and you'll find that around high-speed flight or higher throttle settings, you'll need to make the PIDs less sensitive for them, so that you don't get so much shakes, because it's very difficult to tune a quad for all aspects of flight. And lastly is profiles. So there's 3 profiles that you can select, and all that really means is that for profile number 1 I can have a certain configuration. For profile number 2 I can have a second set of configuration parameters, and up to profile number 3. And you can select different profiles for different flights characteristics. So non-windy days you might find that the quad has better performance with certain PIDs, and you select number 2 profile instead for days that have high winds, where you've actually dropped some of these values so that it's not so sensitive to side gusts. And that's selectable via the flight control through your throttle sticks, and it's a matter of getting the right sequence for that. Now that is also listed in the configuration manual that we downloaded before. So whenever you make changes, don't forget for each page you need to save those changes, and we'll see here that the changes that we've done here have been saved to the EEPROM. I just noticed that we lost these, so I'll just quickly put them back in, and 0.8 and TPA 0.3, and we'll save that. So that's always saved. We can check that. So if you you see here that's loaded profile 2. The value has now gone back to 0, and if we go back to profile 1, the profile is loaded and we have those values saved, which is great. The receiver tab provides us the inputs that we'll see from, of course, our transmitter to our receiver. The roll, pitch and yaw settings should have a trim setting of around 1500, so that was that mid RC setting that we had. You'll see here that the throttle is around 1000. We had, of course, another minimum of 1068 and a maximum of 2000. So if I was to move the throttle up and down again, you'll see it goes to 1970 and 1002, so above and beyond below those ranges that we had previously set. We also see that if I was to flick, so in this case the roll, every time I let it go, it should come back to 1500 or as close to 1500 as possible. So the pitch and even the yaw all center themselves. Auxiliary 1 is a 3-position switch on my unit, and I've configured it on my transmitter so that it works as a 3-position switch. And if I was to flick from position 1 to 2, we see that it goes to the middle and all the way down to the bottom, in my case on the transmitter, sets a 2006 or another position within the software. And back again. I've also configured another switch called Auxiliary 2. It's a 3-position switch, and when I select the middle position in that switch, it activates my buzzer. And I'll show you how to enable the buzzer in the next tab because that's in the mode selection. On the right hand side here, we've got the mid throttle position. I like to set that at 50% because I like it in the mid. You can lower this value to have your mid throttle at 40% or so forth. You can introduce some throttle exponential within the software of the Naze board. Once again, I tend to do this on my transmitter at the moment. However, I've been told that it's a very good option to do within the board itself because the board itself provides better resolution around the exponentials than what you get within your transmitter. So in other words, it has more points that you can reference, and so you actually get better granularity on that throttle curve around the exponential. That also implies for the RC Expo, which is the roll and pitch basically exponential, and you can typically put this at say 0.4 if you want to use the board software to do it, and that of course applies, well, that means that it's 40% exponential, and 0.6 would be 60% exponential, so up to you how sensitive or desensitive you want it to be. And one good one here is RC rate. This is basically tied to the quad's ability to do flips. So the default is 0.9, and anything around 1 will start to give you good flipping capability. And as you increase to 1.1, 1.2, 1.3, the faster that the flips will occur. In other words, the rate of roll or the rate of pitch degrees per second increases proportionally. So the higher it is, the more unstable the aircraft is. I like 1.2. I just find that it flips quick enough for me. High values, it's harder to pick where the horizon is again to give you a level position as you pull out. Here they've given us the channel mapping, so that's the AETR 1, 2, 3 and 4. They've got 2 other defaults, which is for Futaba and JR Spectrum. You can select those if you really like. And this is RSSI on auxiliary, so in other words, we can also have the capability to provide RSSI as an output, or the signal strength on a channel. Any changes that you do to this page, again, don't forget to save it. The next important tab is mode selection. So this relates to those switches that I was playing around with before. If you recall, I mentioned that auxiliary 1 was one of my 3-position switches, and auxiliary 2 was my other 3-position switch. The first 3-position switch is set for my flight characteristics. So the default at the moment is auxiliary 1 has nothing selected. That implies that it's actually rate mode. That's the default. No selection means rate mode. If I was to select the middle position, you see that we actually select horizon mode. So horizon mode is the ability of the board to self-center itself or self-right itself, but at the extremities be able to perform aerobatics. So it's still capable of flipping. The last position is in the high position, and it's angle mode. And angle mode won't allow you to go above 45 degrees, and it self-rights itself as well. So it's a bit more safe than horizon mode, which still allows you to do the flips, but this one won't allow you to do those flips. I did also mention the fact that I had a second output, auxiliary 2, and I've configured it so that the beeper will go off when I select the medium position for the switch. So I'll just select that position, and there we go. It goes green, and the beeper goes off. As I mentioned, the beeper is directly coupled to the Naze board itself. So when it's activated and the switch is selected into this position, it will take on the 5-volt output from the board. So if we look at the board itself, this buzzer connection has a plus and minus, and it's a 5-volt output. So we're actually selecting this component of it. So if you just put a magnetic buzzer on the end of that, you'll get a very similar output squeal. I actually relocated my buzzer from one of my old KK2 boards. I found that they worked perfectly well. There are some other options around here, so you can select mag hold, so magnetometer, heading free, heading adjust, and OSD. To be honest, I haven't used any of these at the moment, nor have I done it with the arm switch. So if I wanted to arm the board with a switch instead of the throttle position, I can do the same. So if I was to take auxiliary 2, that other switch, and I decided that if I wanted to arm the board and say put it into high, so in other words the switch in the lowest position, it would select this quadrant, and if I was to tick that, then the board would automatically arm. I don't like doing that because you might knock the switch and disarm the quad while it's in flight. I prefer to use the throttle setting, so that's how I've done mine, but I've known of other people to go ahead and do this. Any changes to this, don't forget once again to save them. There are some other tabs, servo, GPS. I don't use these because I haven't got a tricopter. I'm not using the servo outputs. The GPS, once again, I don't have a GPS for this either. One that's quite good is the motor testing tab. And if you wanted to test each individual motor, so it's a brand new configuration, to check the spin direction, it's a useful item if you check this box. Please adhere to this. It says remove all propellers. So before you do this, make sure you adhere to that. You don't want to damage your fingers or any other portion of your body. But if you were to check this box and slide this slider up, this would increase the output to that motor. So in this case, it's motor number 1, and the motor would start to spin ever increasingly faster as you increase this slider. Lowering it down, of course, cuts it off. And that's motor number 2, 3, and 4, respectively. So By sliding these up and down, you can see the direction of motion and make sure that it's functioning correctly as well. There is an output here as well, visual for servos. Like I said, I've not used that. So if anyone else does know about it, hopefully they've got a video around that. So just wanted to show that I've gone ahead and removed all the propellers, so they're just sitting there loose. And the reason behind that is I want the motors to spin up and freely rotate the propeller so that I can work out the direction of motion. So let's go ahead and play around with that. We'll check the motor tab to enable the motor testing, and if we slide the first slider up and back down, we see that we get the motor spinning. Second slider up and down, and the motor is spinning in the right direction as well. The third slider up and down, and the motor is also spinning in the right direction. And finally the fourth, and you see the motor spinning in the right direction again. Let's make it safe by just unchecking it all. Raw sensor data, it's just an output to show you that if I was to move the quad around as I'm doing now, that's what the board sees in the way of data, and that's how it's processing it. This is useful to some people. I've never used it myself, but might come in useful if you're trying to do say vibration dampening. You might be able to spin the motors up and see which axis vibrates most, and that might help you alleviate or come to a conclusion as to what might be causing the problem. And there is a logging feature, and I'll be honest, I've not used this either, so I'll leave that to you guys to work out what it does. I hope this has been useful, and yeah, I hope it's gets you into the air simply and gives you a better idea as to what's going on around the Naze board. If there's any feedback, I'd welcome that, because I'm always learning as well, and I can try to incorporate any feedback back into my videos. So thank you very much, and if you like what you see, please subscribe. I appreciate it. Cheers.